very much to everyone for having me. I'm going to apologise in advance. I have a little bit of a cough and I've been talking all day, so I hope I'm going to make it through. So I'm going to share my screen. I've got some slides to share with you, which is, I know a lot of people don't necessarily like, but it does help when we're talking about something that's full of graphs and things like that. So I'm happy to take questions as we go through if they're pressing, but otherwise it might be just better if we leave it to the end, and hopefully I'll answer some of your questions along the way. But if I'm not making sense, interrupt me and I'll try and take a step back and try again. So the wine sector, as with sectors across in all sorts of areas and across the world, are all going to be facing challenges as the climate continues to change. Temperature increases of almost 4 degrees are actually projected relative to 1961 to 1990, and they're projected to occur by the end of the century under the high emission scenario. But that's actually the emission scenario that we're currently tracking slightly above, actually. So in recognition of this, Wine Australia funded a research project in 2016. It was supposed to be a 3-year project, but we blew out and it ended up being more like 4 years. And so what they were trying to do was look at the impacts of climate variability and longer term climate trends on the wine sector. And so Australia's Wine Future, which is the project that I led, was a collaborative research project that brought together about 15 different researchers from a range of disciplines, so including climate modelers, climate impact scientists, viticulturalists, and people who have got a bit more experience in adaptation, climate adaptation specialists. So the project was aiming to give Australia-wide information that was tailored for the wine industry so that we could help those people in that sector take control a little bit more of their future based on good information. So we focused very much on extremes and on heat accumulation because they were the things that they had noticed were already impacting the region. And the main legacy of that project is this climate atlas. So it's an online atlas. Unfortunately, it's not interactive. It's a static document, but it's there to provide the wine industry with climate information at a range of time horizons. So that's what I'm going to talk about today. So what's in the atlas? So in the atlas, we've got the most up-to-date climate projections at the finest resolution that are currently available across Australia. And we've got a separate section for every single geographic indicator or wine region across the country. So once we added in a couple of extra ones for Tasmania, because of its diverse climate, we ended up with 71 of those regions. So we have a separate section for each of them that describes the changes to temperature, heat accumulation, extremes, and rainfall and aridity, which incorporates evaporation. And so we wanted to have a look at not just the future climate projections, but at the climate change that we've already started to see. And I think that's a really important thing because we do know now that climate change is no longer something that we can just put off for the future. We know that it's already happening. So we spent quite a lot of time talking to people in the industry to ask them what was the information that they needed, and we ended up with these tailored viticultural indices. Some of them are fairly obvious and some of them became a little bit more refined. And so as a result, the atlas is fairly unavoidably and unashamedly a technical document. And so we've also included a lot of information about how to use the atlas and how the background information, because obviously once you start talking about climate modelling and climate projections of the future, you need to be pretty transparent about exactly what you've done and how you've come up with the information. And we've also included infographics that summarise the changes that are projected for each region, and that's where you start for those people who might be less interested in all of the details. So here I've got a really long list of the indices that you'll find in the atlas, covering temperature, rainfall and the extremes. We've got the obvious ones, but actually once we started talking to the industry, became obvious, just as an example, that with temperature, they weren't interested in mean annual temperature over the whole year. They wanted to know about growing season temperature. So that's the temperature from October through to April. And we also built in a few indices that give us some indication of how extreme heat might influence people and our ability to work outside as we go forwards. But before we go into any of the details, I do just want to kind of make that the point that we're talking about projections of future climate. They're not predictions. They come out of climate models that are run under different emissions scenarios. The Wine Atlas is based on the high emission scenario, this RCP 8.5. And as I said, this is where we're currently tracking. If we were to tomorrow stop all global emissions, we could perhaps achieve RCP 4.5, but actually in the sort of time horizon that a lot of people in industry are thinking about their adaptation and their planning, you'll notice with this variability across the climate models that actually those scenarios don't really diverge until after about 2040 anyway. So so that we felt fairly confident sticking to that RCP 8.5. But in terms of how we might interpret the data in the Atlas, if our emissions do drop, we did come up with a few different ways as well. And I'll talk about those a bit further on. So in the model, in the Atlas, it's also really important that we use 6 different global climate models, which were all downscaled by CSIRO to give us fine scale. And so all of the graphs that you'll see from now on are actually representing the range in climate models. So we selected those climate models to give us a range of the plausible futures that the projections give us. So there's one which is a very hot, dry future access, and then there's one that gives us a cool, wet sort of scenario. But it is all it's all relative. Even the cool, wet models project warming of more than 2 degrees by the end of the century and very little change in annual precipitation. So the point about the projections is that they're not aiming to tell us exactly the conditions that might be expected at a particular day in a particular year in the future. What we're doing is projecting an envelope of plausible climates in the future. So this is what a climate model looks like. Often people are a little bit surprised that it's not just a regression line or something quite simple. They're actually really complicated beasts. This is the output from the regional climate model that we use, that CSIRO runs. And you can see here we've got 2 cloud layers out of the 17 or so atmospheric layers that are in the model, that we can get out of the model. We've got surface variables. In this case, this is soil moisture. And you can actually, and this is daily time steps. So you can actually see that as the cloud comes over, as it's doing right now, it's raining and the soil moisture is going up. It's filling up the catchments, the rivers and the water, the basins. And then as the clouds go away and everything dries out, the model reflects that. So they're quite complicated beasts, and here comes my throat, unfortunately. Sorry, I'm just trying to mute myself so I can cough. Hopefully this is not going to last too long. So I'd just like to include that so that you can see that there is a certain level of complexity in the models, and that's why we do, part of the reason why we do have quite a lot of confidence in them. So as I said, I think it's really important that we look at the climate change that we've already seen. So these graphs here, we've got the observed change in mean growing season temperature. So this is not from a climate model. This is from the Bureau of Meteorology models that are based on observations. So you can see that we've had what doesn't seem like a substantial amount of warming. It's about 0.8 degrees on average since the historical period, which all throughout this, I'll be referring to that, it means the 1961 to 1990 period. And the current period is 1997 to 2017. So that doesn't sound like a huge amount, but actually, as we know, it's been enough to cause mayhem across the world. We're seeing huge increases in extreme events with storms, tornadoes, bushfires all around the country. So it is enough to be having an impact. And so you can see that there's regional differences. We've got some areas that have only about 0.4 degrees that they've already experienced, and others that are up to that high 0.8 degrees. And that's got to do with the regional climate drivers, obviously, and some of the places that have more of a maritime or oceanic influence that keeps them a bit cooler. Rainfall is also quite variable across the country. We can see here, this is the change in mean growing season rainfall for the same periods. Some areas have dried quite a bit, including in your sort of area, I think, the Goulburn sort of region. But then other areas have actually had increases in rainfall. And that's not really surprising because we know that rainfall is naturally very, very variable. And also because the regional climate drivers are different depending on where you are in the country. So I've sort of tried to, I tried to pull out a region that was perhaps near some of you, and I thought that you were near Goulburn, so I hope that that's right. So this is the Southern Highlands region, and this just shows again in more detail the sort of changes that we've already seen. So we've seen increases in the mean growing season temperature of up to about 0.8 degrees. And in that last period, we have seen a decrease in rainfall. So then the rest of the atlas sort of looks at how the climate may change in the future under these projections. And so these are examples of those infographics that I told you about that give the sort of the region's average for the whole region. And then we've got, for each region, we have these maps that tries to show the variability within the region as well. And so you can see, and I've got two regions here, Southern Highlands and the central north of Tasmania, just to show that they're not always the same across all regions of Australia. So you can see here in the Tamar, you can actually see some of that regional variability driven by the presence of a big river. So we're breaking up the climate change indices into 5 broad categories: rainfall, temperature, extreme heat, which is based on the Bureau of Meteorology excess heat factor, aridity, which incorporates rainfall and evaporation, because so even if you're in an area that doesn't have very much of a change in rainfall, like in Tasmania's central north, as you have higher temperatures, you end up with in general, increased evaporation. So your aridity will actually increase, which is indicated by a decrease in the index. So here I've got an example of some of the timelines that we've got. This is Southern Highlands. We've got a timeline from 1960 through to the end of the century, 2100. The red line indicates a warmer part of that region. The blue line indicates a cooler area within that region. And the bars here are to help us relate the changes to the current conditions that are experienced at the moment. So, for example, at the moment, at about 2020, a hot part of the region is generally warmer in the growing season than Coonawarra. And then as we go forwards into the future, we can see by the end of the century, under a high emission scenario, the warmer parts of the Southern Highlands end up being, in a hot year, almost as hot as the Swan District, which is pretty amazing. That Swan District is currently the 4th hottest district in the country. So we also have different, so these bars here is what I was talking about in terms of trying to incorporate different emission scenarios. So these refer to the global mean temperature. So we can relate these to international policy goals, like, so for example, with the Paris Agreement. If we were to achieve the Paris Agreement, we can separate these data away out of the timeline and say that if global mean temperatures were kept below 2 degrees, this is the sort of temperatures that we might expect in this region, regardless of the time at which that occurs. So another thing that we have in the atlas are these PDFs, probability distribution functions. And basically what that does is it puts all of the values for the time period under this curve. Each of those curves equals 1. So it means that as we can have an idea of, so this basically indicates the frequency with which a value occurs. So here we've got, we have the black line is the current period. That this indicates sort of the mean at the height of that bell curve, and we can also understand a little bit about the extremes of cold and the extremes of heat. And so again, this is the growing season temperature in relation to other regions around the country, and we can see that as we move forwards, our growing season temperature moves quite substantially up higher. So we can see that we have a shift in the mean, but we also have a shift in the variability. And these are slightly different depending on what regions you're in. Growing degree days, I think I'll talk a bit further along down here. So growing degree days is just an index of heat accumulation. We can accumulate those on a daily basis throughout the whole year. And we can also look at it in relation to thresholds. So of course, in the wine industry, everyone's very interested to know how different varieties will be affected by increasing temperature. And this was our way of trying to represent that. So these thresholds can, give or take, refer to the date of harvest of some thresholds. They're not exact because the literature is very much not very straightforward in terms of that. But you might say that Shiraz might need 2,000 growing degree days heat units to mature. So you can see that as we go forwards, again, we've got the black is the current period, and as we go forwards in time, we come towards the red curve. And again, we can see that the time at which that 2,000 heat units is reached moves forward about 6 weeks, actually. So where you might have been thinking of, you might be harvesting at the end of March or in March, we're now looking at harvest, in about January, so not quite 6 weeks. We've got the same sort of idea with rainfall. So each of these blue dots represents each one of the global climate models and a day from that 20-year period. And you can see that there's variability that's captured in the models. We have wet years, we have dry years. Overall, though, for the Southern Highlands, there's very little trend in rainfall, in the growing season rainfall. And there's not really very much of a trend in the non-growing season rainfall, although there might be a slight decline, but you're still getting these quite big wet years and also some dry years. So they're represented quite well in the climate models as well. In other regions, you can see quite strong declines in rainfall. We also have what we call these violin plots, and these just basically show the projected monthly rainfall in 20-year periods, starting up here towards the current period and then going down towards the red towards the end of the century. And again, for this region, you can't really see that much of a change. In some regions, it becomes quite obvious that you've got a decline in rainfall in one month and not in others. And so that's actually quite useful information for when people are planning. Extreme heat is a really interesting one. We've got a couple of different ways of showing it. We've got these thresholds above 30 degrees, above 35 degrees, 40 degrees and 45 degrees. And as you can see, we have a steady increase in days above those thresholds, entirely as we would expect. So this is the number of days per year. And so you can see, for example, that we end up with years above, at the moment, we might be having, you know, in a hot year, we might be getting up to 35 days a year that exceed 30 degrees. But by the end of the century, that might be coming up to be more like 3 months. So one of the things that people were also really interested in was what this means for when you have people working outside. And obviously this is one of the indices that's entirely relevant to lots and lots of sectors. This is the number of days projected to be of severe risk to humans. And so that's basically incorporating humidity as well. So the index basically says that when the temperature is above 30 degrees and humidity is above 60%, then you're at high risk to people. So again, Southern Highlands looks like it, you know, at the moment, it's not something we have to worry about too much. And you've only got a couple of days a year. In a hot year, maybe up to 6 or 7 days per year, when you might not want to have people working outside. But as we go forward into the future, in 2080, we have some increases in some really hot years. And by the end of the century, we're starting to look at about, you know, 15 or 20 days in a year where you might not be wanting to work outside. So one of the things that we've really tried to do is think about how we might use this sort of information. And the climate analogue idea is, I think, quite a good intuitive way of thinking about it. And it feeds directly into being trying to think about adaptation planning for the future. So basically this plot plots every single region across the country. The circle is where we currently sit in that region. The tail behind it indicates the climate change that we've already had since 1961 to the 1990 period. And our axes are on the y-axis, the mean growing season temperature, and along the x, the aridity index. That's the one that incorporates evaporation. And as you can see, across the whole country, you've got a trend towards drier and warmer, again, entirely as you'd expect. So each of these steps is a 20-year time period going forwards. And so if we have a look at Southern Highlands, we can see that at the moment it's fairly similar to Beechworth, and we've had quite a bit of a climate change already. And as we move forwards, we end up being actually one of the places that doesn't have a very close climate analogue, but you can see that there has been an increase in the aridity and the temperature, and you might start looking maybe at the Hunter if you were trying to find somewhere that you might want to think about how they currently manage the climate and weather challenges that region might be expecting to experience in the future. So if we look at Gundagai, you can see that we're at the moment fairly similar in terms of aridity and temperature to Mudgee. But as we step through into the future, I'm just squinting to see if I can find out which one it is, which line we follow. You can see that we actually end up again fairly into that fairly hot, dry sort of part of the graph, and more similar to the Swan District, as I said before, which is one of the really much warmer and drier parts of the country. So I think this is really interesting, a really good way of looking at it, because it means that we can start trying to transfer information from one region of the country to another. So that, I mean, because at the moment, I mean, most of, well, I guess all agricultural people, they're pretty good at responding to variability. And, you know, they have the good years and their bad years. So if we can start to say, okay, I'm going to start ending up having more and more of what you currently call a bad year, but you have certain adaptation techniques that you use to reduce the impacts on your crop or your wine quality or whatever. So maybe they're the people that we should be talking to sort of start trying to learn some of those lessons and move forward at different timescales. So there are obviously different things we can do at different times. So in the short term, you could be doing things like mulching, changing your crop, your pruning of your vines so that you're increasing the shading. Irrigation obviously is another thing. Going forward into the longer term time scale, you might be thinking about how you orientate your rows, where you plant your vines, what slope you're on, that sort of thing. And ultimately thinking about the variety that you're planting. And those things can all be informed by this analogue approach. So just to wrap up so that we've got time for some questions, the big take-home messages are that change is already occurring and those changes are projected to continue. There is quite a bit of variability across the country, but there are consistent trends across all of the regions, and that's that there is a strong warming trend, and that trend will accelerate as the century progresses if we do nothing to mitigate our global carbon emissions. Even if we do reduce global greenhouse gases, there is a certain amount of warming that is committed in the system. So the oceans have absorbed a lot of the carbon dioxide that we have emitted for the last couple of 100 years. And so that will end up increasing, continuing the warming, certainly for the next couple of decades, even if we were to stop all emissions tomorrow. So we know we have to adapt. We have to adapt to the changes we've already had, and we have to adapt to the changes that we know certainly will continue coming for the next couple of decades. Well, next couple of 100 years, actually. So in terms of the same consistent trends across all regions and across the country, we have increased aridity as we have that increase in temperature. There are fewer growing season frost risk days, which I didn't show you, which I perhaps should have, because it's probably in a region where that's of interest. But as you can expect, you have fewer as you go forward. Sort of it's the opposite of that those heat thresholds. We can expect that more intense heat waves will occur all across the country, and there are substantial increases in some regions for that excess heat factor, or that heat stress on humans index. So we know that we're going to have to adapt, and hopefully this sort of information can help people make those decisions. And certainly the feedback we've had from the industry has been really positive, that they now feel a lot more empowered to start making decisions. And for some of them, amazingly, it still comes as a surprise. But I think being able to see these sorts of visualisations means that people really are being encouraged to think about it. And so I think a lot of the information in the atlas is entirely applicable to other agricultural regions and other sectors. Although, you know, the focus might be on growing season temperature, for example, it does overlay summer. So that's obviously going to be of interest to lots and lots of people. So thank you very much for listening. I just wanted to thank some of those partners and the funding body Wine Australia, but this was very much a collaborative project process, and it was also informed very strongly by a really close and useful collaboration with people in the wine region, in particular some of our case study regions, and it was really good to be able to sit down and talk to them about what they perceived their weather and climate risks to be, and the sorts of adaptation options that they feel are open to them.
Thank you for watching. Please subscribe to our CCL channel by hitting the button in the top left-hand corner of this screen. Spread the word of CCL by using the share icon to as many of your contacts as possible. Thank you. See you next video.